Hi everyone. Now today we are taking very important concepts. So here concepts on concave mirror and convex mirror and ray diagrams. Children, from these basic concepts you can expand further and you can draw any type of ray diagram, and even though you are given an object position at different locations on the principal axis. So understand this concept carefully and go further. Children, you are observing, all of you, here I am using a concave mirror. Why it is called concave mirror? This is a concave mirror. So this is a reflecting surface. This is completely reflecting surface with green. Now if you observe here, the reflecting surface curved inward at the center. So this is called concave mirror. We all know that to prepare a mirror, we need a glass substance, and we have to coat with some metal oxides or some paint. So to prepare the mirror. Okay. Now we are going to observe some of the letters on the screen. Now this is called object. So in the physics of light optics, object is nothing but from where you observe the emission of light rays. So now this is the incident ray. We must know how it is incidenting. It is incidenting parallel to the principal axis. This is called principal axis. Okay. So this is incident ray because it is incidenting at a point of incidence. Now it is incidenting with what angle of incidence? For that purpose we need a normal. A normal is a line, perpendicular line drawn between point on the mirror to the between center of curvature. So this will be the angle I. Now this will be the angle R. Okay. Now we have come to know that. So which is angle of incidence? So where the angle of reflection, and which is called incident ray, which is called reflector ray, and why it is called concave mirror. Now if you observe, the center point on the mirror is called pole. Pole to center of curvature, the distance is called radius of curvature. The line passing through pole to pole and C is called principal axis. This is called principal axis. Okay. We have come to know about what is meant by radius of curvature and what is meant by principal axis. Okay. So which is a normal? How to draw a normal? So how many normals will be there? Can you imagine? So infinite number of normals, because we have so many points on the infinite number of points on the circle. So from each point to the center of curvature, there will be so many number of lines. So all the lines will become normals. Okay. Now another ray, to get an image we need at least two rays. So another incident ray, this is another incident ray incidenting through center of curvature. So how it gets reflected? It gets reflected along the same path but in opposite direction. In this way that will go. Okay. Now if you observe the intersection of the two rays, this is the intersection. Here the image is formed. Now this is the point of the image where this is the object here. So this is the image for this object. Now to get entire image of this object, we have to take all the intersection of all the rays, so we get this type of image. So this is about how we get image for a particular object at a particular position on the principal axis. Now you see here it is away from the center of curvature or beyond the center of curvature. So image is formed between C and F. Okay.
Now let us take convex mirror. Convex mirror is a mirror where the reflecting surface will be bulged outside and the inner side will be coated with some paint. Similar to earlier, we have taken an object AO. So we are taking two rays, one is parallel ray, another ray pointing towards C. So you can imagine that the ray which is passing or pointing towards C gets reflected along the same path but opposite direction. So another ray, parallel ray, gets reflected. So that gets reflected as it is supposed to be coming from focus. So the reflector rays in the convex mirror is always divergent rays. So they do not intersect. So we do not get any real image. So to obtain image for these rays, we have to extend back, and A dash B dash will be formed. That is a virtual image which is formed in between pole and focus. If you compare the sizes AO and A dash B dash, image size is very less compared to object size. So that is why to get more field view, we are using convex mirror as a rear view mirror, and in the shopping malls also to view larger area we are using convex mirror. In the ATMs we use convex mirror, you can see there. So from these concepts, the divergent rays, when they are extended backwards, we get virtual image.